use this command here. Very good. After that, we can copy the configuration of the R9, copy the configuration of R9 and pasting on the R9 CLI. This is the R9 configuration. Okay, very good. After that, we can configure the router 8. This is the R8 configuration. Copy from here to the end of configuration of the router 8. This is the R8. Okay, and then we can copy the configuration of the router 7. This is the R7 configuration. Copy and pasting on the R7 CLI. Okay, we need to copy and paste configuration carefully in the R7. Very good. And the last router is the router 6. After configuration of router 6, we can examine the status of the tunnel of the router 6. Okay, this is the router 6 configuration and pasting here. Very good. Now, after some second, we can, for example, check or verify the status of the tunnel 0 in the R6. We expect to see one tunnel in the between the router 6 to router 9. But before verifying this tunnel, let me to talk about this tunnel. In the first scenario, in the scenario 1, we had one tunnel between the R1 to R5, and as you saw, the cost or pass weight of this for example tunnel was 2. Okay, we saw it, pass weight. And as you saw, we didn't use the load balancing between the for equal cost load balancing between the for example T tunnel and IGP for a network on the tunnel tail. Okay, and in this scenario, okay, here this is the scenario 2. We have one tunnel between the for example R6 to R9. Let me to write here R6, then R7, then R9. This is the pass of tunnel. Okay, let me to talk about the pass weight of this tunnel. Pass weight. The pass weight of this tunnel, as you know, is 2. Why? Because here we are passing from 2 for example link, and the cost of the first link is 1 and the second link is 1. Because of that, the pass weight is 2. But here we have another condition about the for example the network that we have here 192.168.254.10. Let me to calculate the cost from R6, okay, to the 192.168.254.10. If we use the TE tunnel, okay, here we have a pass between the R6 and R9. This is the TE tunnel. Okay, after that we need to traverse from the R9 to R8, R8, okay, R9, then R8 link, and after that we need to pass from the R8 to R10 link. Okay, R8, then R10. Now we can for example add the cost of this pass. First, the tunnel weight is 2 and the R9 R8 cost is 1, and also here we have another 1. The total result is 4. And the pass of the for example IGP means this pass R6 to R8. Let me to write here R6 R8 link. After that, the R8 R10 link. Okay, let me to add for example the cost of these two link. The R6 R8 cost is 3 according to OSPF, and also the cost of R8 to R10 is 1, and the result is again 4. Here we have two paths with the same cost. You know that in this example we are talking about a destination IP behind the TE endpoint or T for example tunnel tail. You know that the tunnel tail is router 9 and this is a network behind the tunnel 10. Here, because we have the two paths. First is IGP and the second is the T tunnel, and the destination is behind is residing in the behind of the tunnel tail. We can use the load balancing between these two paths. Okay, I will show you, but you will see that between the tunnel and IGP we are using load balancing. Let me to show you. Look at here. This is our scenario. First we need to verify the status of tunnel in the router 6. Show traffic engineering, for example, show traffic engineering, or we can use show MPLS traffic engineering tunnels. Okay, look at here, we have the tunnel and the tunnel is up and the path of tunnel travels from the router 7 to router 9. Path weight is 2, it's okay. And after that, we can check the routing table, show IP route. Look at here. For reaching to the 192.168.254.10, okay, this is the R6. We have two paths, as you can see here. The first path is from the fast Ethernet 10. This is the fast Ethernet 10, and the second path is from the, for example, fast Ethernet 00. As you can see here, we don't have the tunnel. We need to find the reason. Show run, okay, show run interface, for example, tunnel 0. This is the configuration of tunnel. The reason is that we didn't configure the auto route announce here. We need to add the auto route announce. This is the configuration of the R6. Let me to find it. This is the configuration of R6 here. As you can see, we configured auto route announce, but here we have an error. We received one error message. Very good. Let me to add this feature. Here conf t interface tunnel 0, then tunnel MPLS traffic engineering auto route, then announce. Okay, now we can check the routing table of R6 again, show IP route. Look at here, we need to wait some second. After some second, we can see that we have two paths from the router 6 to 192.168.254.10. The first path is from fast Ethernet 10, the IGP, and the second path from the tunnel T tunnel. Okay, look at here. Now the configuration is correct. As you can see, we are using the load balancing between the tunnel and IGP, and it means that we can use the load balancing between the T tunnel and IGP path when the destination is behind the tunnel tail. Okay, until now we learned about these two rules. First, if we have two paths with equal cost to one destination on the tunnel tail, we are using only the tunnel, not IGP, okay, not IG path. But if we are talking about the one destination network with, for example, two paths, tunnel and IGP with the same metric, we can use the equal load balancing between them, okay. The next condition, let me to write here the next condition. The next condition is that we have two tunnel, okay, two tunnel, and in this condition we have two tunnel with the same metric, okay, to a network. It's so obvious that we can use load balancing between two tunnel in the for example, for tunnel tail or behind the tail, we have the same condition, tunnel tail. We can use the load balancing between two tunnel tail, and also if you use for example a network after the tunnel tail or a tunnel behind the tunnel tail. Here is tunnel, again is tunnel. We can use a load sharing, equal cost load sharing between them, and also here. Okay, I will show you, but for now we can say that when we when we are talking about the equal cost load sharing, in almost all cases between tunnel and IGP, between two tunnel, okay, we can use the load balancing. But here we have one important notification, and that is for the networks on the tunnel tail, we can use only the tunnel endpoint, not IGP endpoint. This is so obvious that we can use load sharing between the tunnel and IGP. I can show you here in the router 6. Let me to configure another tunnel. Okay, before going to the scenario 3, I'm going to configure the next tunnel in the router 6. Let me to show you. I want to configure the next tunnel from router 6 to router 9 again. Why? Because I'm going to show you the two tunnel for equal load balancing. We need to remove the cost tree because I want to use two tunnel with the same for example path weight. Because of that, let me to remove the cost tree. Okay, after that we can continue the tunnel configuration. In the router 6 now we have only one tunnel, show MPLS traffic engineering tunnels, and these tunnels is passing from the router 6 to router 7 and then to router 9. That's it. Okay, let me first removing the cost of the fast Ethernet 10 interface, fast Ethernet 10 IPOSPF cost 3. This is the command we configured before, no IPOSPF cost 3, and also in router 8 fast Ethernet 00, this is the R8, EN